Uh, Gotta love the countdown. Alright, welcome everybody. This is part two of using CodinGame's tools. Oh, and I didn't even check, but yeah, there we are. So, using CodinGame to spread our educational tutorials of Python using Replit. So, very cool age we live in. And I'm going to keep doing it like this until they tell me not to. So, again, like I looked at it and it didn't seem, as long as I meet the criteria. Oh, also, I should mention I am waiting on a call, so I was even thinking of a very obscure way to explain that. I'm waiting for a precise thing that I have to do at a precise time, but I'm just waiting on a call. So, anyways, and I also uploaded part one of this whole debacle to my YouTube channel, so you will be able to see that. Actually, should I throw that in now? Yeah. Also, I'll be fortunate if I don't get kicked out of Twitter. I just made a bold move and just commented, just pitched my stream to. Well, I was partially serious. She needs a vacation, but someone I really look up to is celebrating their 3rd-year anniversary, and I tweeted on her tweet. Then I think I fixed it, because I really would like to see her do. She does artificial intelligence. It's Allie Miller, and yeah, she. So, but again, Twitter. I'm still kind of new to using that. Feel more and more like the old guy anymore, anyways. So, where we left off at, back to the topic at hand. We were dealing with strings, slicing, and different ways that we can manipulate strings, and um, just did another walk a while ago, and I figured I want to do loops. So, loops are very important. Let's see. Let's go ahead and get back into the groove. Let's make a new file, loops.py. Change the permissions of loops, and there we go. And I was just looking at it, so we got pound bang slash user slash bin slash environment python 3, and just a test, but I'm pretty sure we got it. Allo. Okay. What? Oh, whoops. Oops up high. Hello, okay. So we got that. Oh wait, are we lagging? No, looks okay. Oh no. I'm trying to keep all this stuff to a minimum. There we go. Actually, we can just take that out. Alright, so loops. How do we do it here? We just got into it. Alright. I don't know. That's it. Loops are very useful when needing to do the same or let's see, because it's not the same action, but it's slightly, yeah, it'd be the same action. To do the same action multiple times iterations. There you go. You like that? Let's sneak that in. So start getting familiar with that. Um, for loops are usually, there we go, usually better when the amount of iterations is known, and while loops are usually better when the number of we'll just keep going, iterations is not known. However, okay, and then also, this is getting pretty lengthy. Let's see. Yeah, I'm going to put it on a new space. However, you can pretty much do any process algorithm with either style of loop. There we go. I mean, with some, it takes some doing, but you can do it. I mean, it's definitely doable. Alright, so you can also use recursion. Because I snuck that into the end of, I'll do punctuation here, I guess. I don't know. Alright. So, I think we were just printing out. So, for, well, no, let's do. Iterate through every char. Oops. In a string. Okay. Test string equals hello world for char and test string. Oh. Print char. There we go. Now let's alright, what's wrong? Name test string. Oh yeah. It's just shorthand. There we go. And as you can see, it loops through and prints out every character in this string that we declare right here. Or, yeah, we declare here. Sorry, don't want to get it mixed up. Technically, it should be declare for variables, defining for functions. But either way, you're creating this. So you're declaring a variable here. And it's always good practice to declare your variables at the very beginning before you get going, especially since you're going to be using them. So if I were to try to declare it after, I should have actually pointed that out. I just kind of assumed. So it's like reading, the way that the computer looks at the code, or the interpreter. And then, so if we try to do this, you'll see that there's a red squiggly, there's an error right here, and if we tried to run it again, we would get an error. So, and it would say line 13, I don't know what this is, you haven't told me what this is. Oh wait, here it is, but it's not going to do that for you. So, I mean, I suppose there are ways to do it where you would have to, but it's just best practice to, you know, declare your variables first, then you can use them. So, and also, and I'm kind of in a bad habit with this with CodinGame clashes, I'll declare variables as I go. So, sometimes I'll declare them down here, but really you should declare all of them up here unless they're within a function, and we'll actually, I think we'll get into functions this video. We can do loops, functions, let's see, basically mimicking what I already have for Java, and then, I don't know, I still need to go back and update the website, but if we were to go to, whoops, yeah, looking at Java, I have examples for, you know, pretty much all the basics on this one, and then I have an advanced page, but loops, switch statements, which don't exist, we can go into dictionaries instead, which basically kind of replaced them. And then, yeah, so anyway, so we got that, that's a for loop, and that goes through every char. Oh, okay, sorry. Alright. I'm trying to think, because I want to make a note of, you don't have to declare an index. So, let's see. Indexes are used to keep track of what we're working with for each iteration. Okay, and then, like right from the beginning, let's see. Well, I guess that should be with while loops. I mean, because it's really hard to do an, I mean, I'm sure it's not impossible, but it's a lot harder to do an infinite loop with a for loop. So we got for loop. Actually, yeah, that's a good segue into a while loop. Um, you have to manually change the index. Let's see. Actually, no. You could still use range, but anyways, usually with while loops, you have to manually change the index. So, well, we'll go ahead and be careful. Infinite loops are created. Oops. When let's see. Best way to call it would be like a terminating condition is never met, i.e. the index never changes, a count, let's see, count never changes, or whatever condition we decide for the loop. Oops, I was trying not to make it another line, but whatever. For the loop. Alright, so let's write a while loop. We still have test string, so we'll go ahead and use it again. But now we'll have index equals 0, while index is less than length test string. Print test string at position index. There we go. And index plus equals 1. Okay. Let's go ahead and run it again. Clear that out. Alright. So now we've got it twice. So we've got every character, but we're just moving the index, and that's what we're doing here, is we're incrementing it's the kind of, whatever we're doing in this line, it's, a counter, but also we're using it as a condition that's going to be met once it becomes the same size as the length of the test string. And so that's what's going on here, is this is actually the length function, and we're calling it on our variable test string. So yeah, and we start at 0 because indexes are 0 based in computer science, most of computer science. Sometimes it changes to 1, something you need to be careful of, but most of the time 0 will be the first part. So you notice we print out the very first character before we change index. Otherwise, we might as well have just said index equals 1 and start from there. But if we did that, we would miss out on the capital H. So, we can even see what that looks like. Let's go ahead and clear that out and then run it again. There. So there we're slicing off the H. And so, yeah, and then think about what we were just talking about in the first video is with strings. We've got slicing here, so you can actually target. Oh, that's a good point. We did it here, but let's actually add to that. Print single char at a certain index. There we go. And then so that would be print. Whoops. Nah. That's where I accidentally agreed to the suggestion. We don't need it capitalized, all fancy. There. Print test. This one I spelled string all the way out, but anyways, we could do at 0. Let's see. This also, let's see. This also works backwards with negative index indices? No, we can do it this way, with a negative index. Oh, there we go. Okay, so I'm pretty sure it saves automatically, so feel free to run it again, but we're going to loops. Alright, and then so you should, right? I'm trying to make it not super lengthy like the website is, or super wordy, but if anybody's just looking at these replits, I don't know, without the video, that'll be okay. So we got a for loop, we got a while loop. In other languages, sorry, there are do while loops. However, let's see, Python doesn't use them without some extra effort. There you go, some extra doing. So, I mean, you can do it. You could replicate the behavior of a do while loop by performing the action or whatever you're trying to do with the loop one time first and then doing a loop, but there's really no point when you can just change the index or change the condition to include, like, say you're trying to do something like calculate the Fibonacci sequence, or you're trying to do something across, so many times. If you're trying to calculate that first one, it's hard, but often you're able to do it. So yeah, just mentioning the do while loop, because that's one of the things that I learned when I was learning Java, and so for anyone who's going into another language, I mean, just be prepared that you might encounter it, but again, a lot of times you can get away with using it, or without ever using it, so. And then recursion, so let's do that. Oh, recursion, we need to actually briefly talk about functions, but that's a good segue into functions, so. Although now we need to, actually I think we can do it, kind of a hybrid style. Let's try it. So, to demonstrate recursion, we need to define a function. The concept. So if you're not familiar with recursion, it's where you have a function call itself until a certain condition is met. So it's like a loop. I mean, it's very similar, but it's kind of hard to wrap your mind around in the beginning. But yeah, it's a function that calls itself until it hits a base case, and that base case is usually like 1 or 0 or some kind of situation where it's like, okay, then break out of this loop. Because logically, it is another loop structure. It's just the way you set it up looks kind of scary, and it's also easy to write infinite loops. So let's see, the concept to demonstrate, okay, is where you have a function that calls itself until, and this is going to be wordy too, a condition is met. It's also easy to write infinite loops with recursion. There we go. No, not a recursion error, just recursion. There we go. Okay, so define recurse this n if n equals 1, oops, okay, print this is the base case. There we go. Else recurse this with n minus 1. Okay, so whatever we call this function with, also I just realized, so there's a potential for an infinite loop if you called this with a bad function. So if you tried, or a bad call, if you tried it with like negative 100 or anything less than 1, this is going to be an infinite loop. So, I mean, you might, like if you're not sure what the user's going to put for input for this, you might want to put a check against that, but for now, and all you'd have to do is like maybe set a counter, like set a timeout, like if such time for, I don't know, a counter gets too big, and then keep track of how long, although you'd have to pass the counter to. So that gets complicated, so just don't call this function with anything less than your base case. If you're going to break your base case, then you kind of deserve to have an infinite loop. So, and the worst case that happens with an infinite loop here is it'll just crash it. It might crash my connection, so I don't want to, test it out. If it happens by accident, it happens, but, So, anyways, now we got to call this. We got to print. Actually, no, let's try to just call it. I'm going to try to get away without, let's just do 10. And then we'll also print to show iteration. And then we're also going to add, oh, and I guess I should say, a trick or a thing with Python is the print function actually requires strings most of the time. I've noticed in CodinGame, when you're doing like the clashes and stuff, it doesn't necessarily matter, but just in case, just remember that you can cast variables to a different type, so we can cast it to string, and we could do n. So this will keep track of which iteration we're doing through the recursion step. Now let's see if this works, and also, well, we'll see it. So I was going to say I'd like to comment the other one. Okay, so that actually worked. We didn't have to have a function, so that's cool. So also I'm doing no spaces between. I like to try to keep things consistent. Alright, and also see I broke that because the indentation wasn't correct. So also you'll notice if else, that's kind of back to control flow. Those have to be indented as well. I don't think I mentioned that with the control flow. We can look at that example again. So those are all our test cases, and that's where we did use a main method, or a function. Sorry, you might hear me call them methods as well, because in Java they're known as methods. I think there's a difference between functions and methods in Java where it's like implicit use or explicit, but or you have a variable or it's the dot operator or whatever. But here, we just have defining functions, and notice, and interestingly enough, these are way indented in, but it's uniformly indented. So we have an indent of 1, 2, 3 tabs. Now that is kind of funky, bad practice, but let's actually go ahead and fix that. But I mean, that is a trick in CodinGame with the code clashes. When you're doing shortest mode, you can just do a single space instead of the whole indent, which counts as 4 spaces. But if you're not worried for characters or the length of your code, then I would suggest you just do that. So, and make sure, whoops, return. Jeez. No, thank you for the help, but no thank you. Alright. Then we got that. This is often how I lose shortest mode clashes. So I'll be doing something like this, and then I'll run out of time, and then I'll have broken code. So, and, if you do go to university and get a degree in computer science, you'll learn very quick that if a program doesn't run, you get a 0. So, there's that. Alright, so back to loops. So we got recursion. And of course we still have all the other printout. That's what I was going to say. I don't know if I actually said that or not. I just thought it. I was going to take out the printing of it. Sorry. So yeah. And again, it's very similar to a loop structure like a for loop or a while loop. Basically, every time you're calling this function, you're calling it with one less than whatever you started with. So, and we're constantly checking every iteration or every time through using this loop. We're going to see, okay, is it a 1? Then we'll do this. Otherwise, keep doing this. So, and we could change this to, 1 and then have it not even, let's go ahead and clear that out. And then try it again. So then it just happens once. And so we don't actually see this, this iteration of this. So let's change that back to 10 though, because that is more interesting to see all the messages. And you get to see a countdown too. So clear that out again. Okay, so again, you've got all of the chars being printed in this way, with a 4. And I'm thinking there isn't a real clean way to do this, but I was thinking maybe even just showing recursion with that. But well, actually, let's try it. This will be an interesting test to see the scope of the variable that we declared way up here. So we're still using test string in both of these loops. So let's try it here. Let's print test. Oops, no. Test string at. This time. Oh no, we could do position 10 minus n. Let's see what that does. Also, let's take this out, because otherwise it's going to get gunked up with that. Okay. Oh wow. So it works, but so we don't reach, we did 10 minus n, so that actually, well, let's go ahead and mute these other ones so we can see what's going on. Okay, just to see. Alright, so it does start out at the beginning, but it doesn't go nearly enough. Oh yeah, that's because the number of the characters in the string. Sorry, so if we actually did... Ooh. I'll actually do this real quick to show you what can happen. So let's do this with 15. Is that longer than the word? So we're going to get an index out of bounds error. Hello world, hello. Wait a minute. Did that? Sorry. We should have gotten an index out of bounds error. Let's do 150. There we go. Wait. Yep, string index out of range. That's what I was trying to show you. So this is a common problem, and also it's a common problem with all the loops. So like here, we're printing out at the index, and we know to start it. Actually, I changed that to 1. We need to change it back to 0. If we want to start it from the beginning, if we actually want all of hello world, yeah, because we're chopping off the H. To fix that though, and to make it scalable, this is a concept that needs to be learned early on as well. So to make it scalable till it works any size variable, we could do length of test string. So by doing that, doesn't matter what it is. Also, I want to say it's well, let's try it and let's see if we have a problem. It's either that or it's either that minus 1, because hello world, I mean, it looks weird, but, and then also if we wanted the extra thing, we could do print test string at position n. So that's one of the reasons we're missing characters. Let's see, so if we do that, let's see. Oh, that does look weird. Oh, n minus. So if we did like 10 minus n, which would be 10, so at 9. Okay. So see right there. I mean, just trying out little things. There could be bugs. And those are bugs where it doesn't make your program crash. It's just a concept error. Like, it's not what you were expecting. So, and again, we're starting with that. So I'm trying to think of how we would do that. Well, we wouldn't do it very cleanly, but this also demonstrates scope. And what I mean by scope is we declared this variable all the way up here, but since it's the furthest most left, like think about it, like this is a global variable. So this will be available throughout this entire file, and not in other files, unless we explicitly link them, and I'm not sure how that goes, how we go about doing that in Python yet, but like in Java you can include other things and use variables and stuff from other ones. But anyways, here we've got this variable and we're using it for the for loop, and we could even use that index down here if we wanted as well. So yeah, we're just calling the recursive function with the initial call to start it off. And something to point out too, since we're going to get into functions. Let's see, we're at a half hour. Yeah, we got plenty of time. So we'll do functions next and get kind of, I'm almost wondering, we could do an encryption. Anyways, we'll get to that in a bit. But this actually doesn't do anything if you never call it. If you never actually tell the computer, hey, go use this function, you can have functions that just don't do anything. So to show that, there you go. So nothing happens. I'm going to go ahead and revert this stuff back so it does work if people wanted to come and try it. So, and also that's the link right there in the chat too. So, or wait, no, that's YouTube. Sorry, let me put, I mean, it's the first link, the Replit Twitch, yeah. Eventually I'm going to add that bang links thing that streamers do. Haven't quite gotten there yet, but I will, so I promise. Now with everything activated again, we actually don't need this. I'll leave it there, just comment it out so people can uncomment it if they want to look at it. But really, I mean, if we were to run this again, now we get all of the printouts. So you can see hello world, and it's now complete. It does have the H. Then here, hello world, and then we hit that base case and we're just missing, we're actually missing the one at 1, and then also the character at position 0, so the exclamation point, or sorry, 10 minus 0, which would be at position 10. Can we do that with this? Sorry, I want to try this real quick. And oftentimes I don't even know. I gotta test it to see it. So, doesn't look like it. I think, yeah, it's because we're terminating at this point. So if we were to go -1, no, 0. No, I think it'd actually be -1. Let's also take this back. Clear that out. Okay, there you go. So actually -1. If we set the base case, and see, that's how I was meaning with, you could do a do while loop by adjusting the index or the condition to be met that tells the computer, okay, stop doing this loop. You've satisfied the condition, break out of the loop, and then move on to the rest of the code. Which there is no rest of the code for this file. I think we're pretty much good here. But we can do, I want to say, could do a basic encryption, a Caesar cipher, because that's what I did here. That's also kind of discussing two concepts, because there are switch statements in Python. They get changed to dictionaries, which you can do the same thing. Like if it's this, then do this. Dictionaries are a little different though, because here you can actually do some code. You can print something, you can execute something. Whereas I don't know if you can do that with dictionaries. I don't usually do it myself, but I haven't seen it. But anyways, let's get back to, my point was doing an example of rotation 13 or a rot 13 encryption algorithm for a good example of a function, because that's what I did with Java. Actually, no, these are all case statements, switch statements, sorry. So anyways, not something you need to worry about, because as far as I know, they don't exist in Python. So what's this? Well, I think I'm good on that call, so I'm going to go ahead and turn the sound back off. It drives me nuts. Alright. Anywho, so let's make a... Let's see, do we want to do just... Let's call it functions. Yeah. So touch functions.py. Chmod it. Make it executable. There we go. And go into functions. So, go and clear that out. Again, we do pound bang / user / bin / environment python 3. Then, just to verify it worked. There we go. Okay. Probably don't have to keep testing that every time. I think we got it now, but sometimes it's just good to be safe. So, I mean, we'd figure it out pretty quick anyway if there was an issue. So for functions, yeah, let's do kind of like a twofer. Let's do rot 13. This is also an example of dictionaries, which are very useful objects in Python. There we go. And I don't know, punctuation, no punctuation. I don't know, I keep going back. Oh, that's interesting. I don't know what I pushed there. Anyways, that's another dunder thing, double underscore. But we would do define rot 13. Also, it's probably a good idea to point out you can't use certain characters in declaring variables or defining functions. For instance, if we did a $sign variable, I think we'll get in trouble, equals 9. Yeah, so you can't use $signs in Python, which is counterintuitive because in a lot of scripting languages, that's actually how you do variables, is you start with the $sign. So for here, it's a no-go. So we have a function, define rot 13. We need to put a colon at the end, and then the indentation. So kind of like as previous, when we did the loops, same thing. We got the, I think there's an E at the end of recurse. It's kind of bothering me. Okay. So anyways, same thing. We have a define keyword or reserved word. The name of the function, which you can do snake case, which is, oops, don't delete it. Where you use underscores to separate words. Oh, and you can't have spaces too. Sorry. In fact, I'm going to put that. Let's see. That should actually go back in variables too. So, like the naming convention. Primitive data types. Just put it way up here. Variable names can't have certain special characters, spaces, or be reserved words. There we go. So that covers all the bases there. And I don't see punctuation there. I don't know, that could drive me crazy too. Let's go back to functions. Okay, so now we've got rotation 13. So for anyone who's not familiar with rot 13, it's an encryption algorithm also commonly referred to as Caesar cipher. And basically it's where you replace each letter with the exact opposite letter. So when you're thinking like color wheels, the composite colors or the colors across from each other, think about the alphabet in a circular function, and so each letter, its counterpart, or the one exactly halfway away from it is the new one. So, and by new one I mean the ciphertext. So when you're doing encryption, and this is very basic encryption, don't ever try to use this, it's not secure at all, it's one of the first things cracked, but anyways, with encryption you have your plain text and then you have your ciphertext, which is when you perform an encryption algorithm on it, you change it to a certain new form. So to show this, let's see, I think there's actually a way to do it, and I encountered this in one of the clashes recently, where you actually call the alphabet a certain way. So there's a way you can retrieve the alphabet and then do this another way, but for the sake of this, and I already wrote it, we're going to use dictionaries. We're going to do alphabet dictionary. Okay. And we'll do see. I'm trying to think if I want it zero based or yeah, we'll just keep it 1. Go ahead and type it out. B. Oops, that goes to 2. Actually, what we can do, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. That'll be 26. Z, 5. Now let's go forwards. I struggled doing it backwards. Let's see. D, that's 4. E is 5. F, 6. G, 7. H, 8. I, 9. J, 10. K, 11. JKL. Really test if I even remember my alphabet. Oh, what's going on? Okay, so, well, we did it, the comma, there we go, and then there. And actually we might have to do that again, because I'm going to start adding, yeah, we'll see. So this is N, O, P, Q, let's see, 17, no, 17, element P, Q, R, there we go. So yeah, now it's, okay. Alright. QRS. That's 19. T for 20. U. Do we do it right? Getting in there. V. 2. I guess I could be keeping the 2s. Let's see. T, V, W. X. There we go. So that came out all right. So now we have each letter in the alphabet, lowercase, mind you. I mean, that's another thing that you need to be careful of. What's this? What's wrong with this? Invalid syntax. I don't get it. Let's test it real quick. So this is how you would access something in a dictionary. Oh, whoops. And also notice I have it all the way to the left. You need to indent it to make it contained within the function. So that's a good example where if I did that, it wouldn't be able to reach it. In fact, let's try it. So we'll see the error that pops up. Alphabet. Yeah, it won't know what I'm talking about. Alphabet dictionary of A. So let's clear that out. See? Okay, actually this is invalid syntax. Equals. And then it's just never used. Okay, there we go. So sometimes you'll get this one. I think this is the first time we've seen it in Replit. That little different colored squiggly. It's like kind of orange or whatever. So that's not necessarily an error. It's more like a, hey, you made this, but you're not using it. What's the point? And then here we do have an error. So if we were to actually, so I fixed that. Try to run it again, and then you'll see that it's not defined. It's funny. That directly contradicts what I was saying in the first video where it's defining a function, declaring a variable. Well, this variable is never defined or declared. Wow, that's funny. Anyways, so it doesn't know what it is. But if we were to indent it, bada bing, now it knows what it is, and now it'll actually do something. It'll show us clear. It'll show us what's at that position. So let's go ahead and call it again. It should. Oh, right. And also, I forgot, we're not calling this function, so we need to do one more step. This one needs to be on the outside, or out of this scope. Then we're actually going to call that function, so rot 13. I think we can just do that. Since we have the print here, I mean, if you don't see it, then that's something to look at. You might actually have to say print whatever route 13 does. But since we're telling it to print in here, that we're good. So, and we see it's 1. We can toggle this to anything we want, Z, and then get out of here. Try it again, and now we see 26. So this will print out whatever value on the right side of this little section, or this grouping, or tuple, or corresponds with the key. So for Z, it looks for Z, and then it sees, oh, there. However, and I kind of mentioned this a little while ago, the lowercase uppercase thing, if you try to do an uppercase Z, well, let's take a look. It doesn't work, because it has a key error that there is no value that corresponds to an uppercase Z. So to get around this, oftentimes what you need to do is you need to force everything to be either lowercase or uppercase, or you would need to make a dictionary twice as big, which I really don't think there's all that many times where you need to do that, but you could. You could just copy and paste this again. Actually, let's see. Another good thing to have, let me go ahead and pull one up, is an ASCII table. So it refers to the basically indexing of all the characters, all the known characters. Let me see a good one here. Okay. Can we just throw this up here? Ah, that's not. It's not great, but anyways, this is what I'm talking about. Let me see how that looks on the stream. No, there's so much of a delay. Or no, it's not in there. Can't see it. There we go. Can you see it now? There. So this is an ASCII table. It's not the best one. It's just one that I clicked on. But if you search ASCII table in Bing or Google or whatever, you'll see that there's a decimal value, a hex value, an octal value, and then a char value for just about, a lot of stuff. And these are the same values that go into your computer when you hit keys on a keyboard. So you get a number, and there's another one. Whoops, I clicked it. to another one. But here you go. And so notice that lowercase letters correspond to these values, so decimal 97 to 122, whereas the capital letters start at 65 and go to 90. So a little counterintuitive there. You know, capitals are actually before the lowercase. So, but just something to be aware of. And there's different ways to get these values. In fact, let's go ahead and, so that's an ASCII table, and we don't really need it for what we're doing, because I'm going to show you another thing. Print ord of this, and you can keep piling on functions upon functions if you want. You just need to be careful when doing so, so that you have corresponding parentheses at all times, and then, yeah. But if we do ord of that, trying to think. Well, I just closed the ASCII table. Oh no, it won't work with that. Sorry, we would need. Let's actually take that away. We're not doing ord on that. We would just do. In fact, we can do this outside of the function. Print ord of z. There we go. Let's clear this. Oh, what's going on? Guess it forgot. Okay, so functions, whoops. Oh, right. We also left the bug in there. So let's go back to that. Let's get that off the screen. Clear and run it again. There we go. So what's going on here is we're still getting, we're calling the function second. So you can kind of see the order of, not order of operations, but order of how things are going in our script or our program or whatever you want to refer to this as, our file. We're doing this first. So the ord of lowercase z is 122. So, and if I didn't close that ASCII table, feel free to look up an ASCII table on your own, but that would correspond with lowercase z. Now if we did uppercase z, remember we said all of those were less than in value, then we'll see what that is. In fact, we'll leave that other one up. So that corresponds to 90. So that's also useful whenever you're doing encryption algorithms, or a lot of challenges on CodinGame require you to be able to use or manipulate the positioning of letters, the numbers that correspond with letters, all sorts of stuff. So, but these are different ways that you can work with the numbers. So actually, let's see if I can do this from memory, without looking at the Java rot 13. So we're going to have a plain text, and it's going to return a ciphertext. Okay, so it's going to be fed in plain text. And see, it's getting mad at me because it doesn't know what ciphertext is. We haven't declared it. So again, usually declare all your variables, or define, according to the bug that we had. But anyways, create all your variables up at the top of your function. That way people see it right away. You know what you're working with, and you avoid stuff like this. Now granted, this line, the return line, is always going to happen at the end of your function. So I guess we haven't really mentioned that, but anyways, yeah. So let's make ciphertext. And then we got to set it equal to something so that Python knows what it is. I mean, it could be a 5, it could be, a 5.0, it could be this. So, but doing this tells the interpreter that we're using a string. So it's not super exciting, and also we wouldn't see anything. So even if we set this to hello world, it would be returned by the function. Let's go ahead and get rid of this so it's not as confusing. Although I might just leave that in there, so if you want to play with it, you can uncomment it. But if we do this again, oh, and also, sorry, we got to supply some plain text. Plain, there you go. Okay, and it does nothing. So to see that a little better, let's clean that up. And it does absolutely nothing. Now, if we did a print command to see what is returned by the rot13 function, then we should see something. There we go. And we're seeing whatever ciphertext is. So although we're getting set up to start changing ciphertext and actually doing an encryption algorithm, but for now we just hard-coded it into hello world and we're returning that. And then down here we're printing what is returned from that function. So now, let's see, doing it this way, we do need to basically duplicate this. So this isn't going to be the cleanest. And then this would be, let's see, I'm going to name this number dictionary. Okay, and now it's backwards. So how's the best way to go about this? So we basically got to reverse it. Might be easier to just type it. Oh, it's going to be painful. Now we'll do that. Paste it and then backspace. It's not always glamorous in the world of computer science. Oh, and also, it's starting to get a little dark. See, we've been going for about an hour. Probably do like a closer to like that 2-hour thing. I think that's about good. And we'll talk about functions and what was the other thing we were going to talk about? Forget. I'll figure it out. Okay. Oh, what happened? Now we gotta do a double. There we go. Oops, forgot the colon. Alright, and basically why I'm doing this, let's see if I can explain it while I'm doing it. Oops, so I need to do that. The reason I'm doing this is we need to be able to convert it back. So back and forth from a character to a numerical value. So that corresponds to that character. In order to essentially change each character into its corresponding ciphertext character. And over halfway done. And again, there are easier ways to do this. Like you can manipulate just by using ASCII values. There's some built-in things that you can use, but I like to see it out especially for the first time. And again, these are tutorials that I'll be having on the YouTubes, so it's good to see it like this. And in the YouTube video, you can fast forward with all this. Uh-oh, what did I do? Did I nix the... Oh, just an extra one of those. Okay. Do that. Uh-oh, are we good? Okay. Sorry, it gets a lot more exciting here soon. So, or at least if you're nerdy like me. Okay. Oops. Okay, so we need the colon there. Alright, so now, just to kind of demonstrate real quick what the purpose of all that was, let's throw in a for loop. Oops, for loop, for char and plain text, print alphabet, no, dictionary of that char. Yeah, actually, I'm glad you brought that up because that's what I was talking about. There are better ways to do this, and that string.ascii lowercase. Actually, I think, weren't you the one that brought this up when we were clashing the other day? Oh yeah, you'd have to import string. And that's another important concept, the concept of importing. So let's actually do that. Because yes, that's awesome that you bring that up. Thank you. So import string. This is the more verbose way of doing it, declaring a couple of dictionaries. But yes, you're right. The better way to do it, or the more concise way, would to do that. I'm going to comment it out for now real quick. So let's do... Actually, no. Let's go ahead and declare it. So better dictionary. See? Another way to achieve the same goal. Oh, and then also, that's right, it actually, I think I can just copy and paste this in. Okay. Alright, nice. Yes, and that is the other way. Oh, I think I'm missing a parenthesis. Yes, so another way to get the... Wait, what's wrong here? Invalid syntax, hello world, better dictionary. Let's see, is it equals? No. Oh well, we'll fix that just real quick for this one. To show the functionality of the other dictionaries, let's see, we'll print the alphabet. And yeah, backslating totally allowed. I'm glad you brought that up. So yeah, thanks broken vocal cord. Either is fine, but the one I put is nice for short. Yes, and that is definitely relevant for CodinGame code clashes. You want to be doing stuff like this, and especially complex. Yeah, but for now, let's see if we get that. And also, I'm going to do, well, actually, I'm going to leave it like this, just for educational purposes. So we're going to see there's a problem. Actually, I had to, oh, not. After a certain time, you got to retype the thing. So yeah, so there is an actual key error on the first one. Because remember, we have capitals and lowercase. So a way to get around that is you could do char dot lower to enforce that it's a lowercase char dot lower. And so now if we did it again, clear that out. And there you go. So that's the corresponding numerical value for each letter. And then you could do, or well, to get into the rot 13, we're going to need a cyclical array. So that's okay, good. Let's see, import string. We did. Let's see, enumerate. I think looking at the syntax for this one, because we got string. Yeah, we were importing string. But if we're doing this, and if we were to say print better dictionary, it's wrong. Invalid syntax. Let's see, is that... Well, either way, we can address that in a sec. But for now, the original one, to keep doing .13, we would do a cyclical, let's see. Oh, okay, I took off dictionary, but that is really the, okay, dictionary.enumerate. Perfect, that makes sense. Okay, but then did it, wait, am I shortcutting it? Lowercase start. What's wrong with it in this one? Well, and also I'll keep setting up that cyclical index too while we do this. So, whoops, need to go here, and then, and what I mean by cyclical is once you reach a certain point, you need to change the index back, so so you're always feeding the dictionary a valid term, so we avoid that same thing where we had that issue with the capital P. So, let's see, missing prints. Oh, gotcha. I did not see that. Thank you. Alright, and then if we do that, let's go ahead and throw that in there. Alright, so now as you can see, you actually achieve the same thing that it took us so painstakingly long to type out, but you get the same thing, and that's why I named it Better Dictionary, because you're so right. Like, I mean, aside from problems getting familiar with this type of concept, it is the better way to go about it. And it also gives you a lot of power. So we have the start here. You could really start it at anything. If we want to start it at 0, let's go ahead and clear that. See, you'll have A as the 0 index, whereas if we were doing it this way, we would have to go through and retype every single value of... Actually, saying it that way, this is a lot better dictionary, so yeah, word. So... And also, I'm trying to think, you could do it reversely. Well, either way. So we're going to change that back to start 1, and we can use it, I'll do it both ways. So we can use the better dictionary or alphabet. Technically they're the same thing, so if we did this again, now that we change it back to the indexing starting at 1, you'll see that all of the values correspond now with 1 being the initial one, and Z being 26. So, which is what we got here. Although, wait, as I even highlighted it, apologies, it takes place of the number dictionary. Sorry. So to do the other way, I'm not too sure. So if you know how to do that, we can try it. We can play around with it. But for now, to finish up the rot13 thing, the indexing, or the algorithm, would be to take whatever you get from the dictionary, the numerical value, add 13 to it, and then if it's more than 26, you subtract 26 from it. It's either 26 or 25, because we're going to have an issue with the 0 and 1, because I think I might be thinking it with the 0 index, but anyways, so for every character in the plain text, we want to do, and also we should do variable up here, new index equals 0, just to initialize it to something. And then in here, we'll do new index equals alphabet dictionary of number dictionary of char dot lower. think that should account for anything. Print new index. And let's actually see if it has an issue with. Okay, so because it's going to be an int. I'm going to clear that, and let's take away, so we don't keep printing that dictionary. Better other, nice, thank you. Yeah, we'll throw that in there too. So, okay, so we did it a little differently. So it's the key error. I did that backwards. So we need alphabet dictionary, and then we need the number dictionary. Got it. There we go. So now we're seeing that we have some indexes. Doesn't look like anything's over 26. So, oh, because we haven't done plus 13. And we can just tack that on at the end. So let's do that again. Ooh, and that's where we need to make it cyclical. Or wait. Line 28. So I think we just get around that from casting that. Oh man, then it freaks out. That. Okay. Well, let's go and clear that out. Invalid literal for int with base 10p. So it's on line 28. Oh, this is what happens when you're doing it in real time. I'm going to go ahead and copy and paste that better dictionary in here too before I forget. So thanks, Broken. We're going to do that. And throw that in here. So better other ones. Ooh. EK for K, V, and interesting. Well, we'll look at that here in a bit. As far as the issue that we have going on here, if we look at... Oh, actually I do like to keep that. Whatever. For the... Code should be about that wide, I think, if you're thinking about terminals and stuff. So, let's see. Doing a lot of stuff here. I was just going to print out... Actually, I do like this better like this. So, sorry. There's a lot of stuff going on here. So if you look at it from the inside out, we've got char.lower on the innermost part of this line. And so whatever this character, whatever this character, this char is, in plain text. So remember, we're going to go through each character. We'll start with lowercase p, since we're enforcing it with lower. And then that's the key for alphabet dictionary. Let's see if we can fit all of it in one screen. There we go. So it takes lowercase p, sends it to here, gets 16. Okay, so then this becomes 16. So then alphabet dictionary, or no, this all becomes 16. And that would make sense. We're trying to find... Oh, man. I think we can just take this off. Because this is how we get... That's right. That's what I was doing wrong. Okay. So now if we cleared this, I'm just looking for the new indices. Or the... Kinda indices? Yeah. So here we go. And you'll notice one of them actually does break the... Or needs to be looped over. So then we would... subtract 26 or 25 from it. So... Here we do if new index, let's see, if I can spell, oh man, index greater than 26, new index You could do minus equals, I believe it's 26, because we wanted to start back over at 1. Yes, let's try that. So now if we did it, you'll see that the one that violated, and this is for the new character too, when we're about to start actually creating or building our ciphertext to be returned. In fact, let's go ahead and do that. So now let's take ciphertext and make it an empty string, and then ciphertext plus equals number dictionary of new index. If all things are working, let's go ahead and take that out. Okay, we're actually printing whatever the ciphertext should be. So let's go ahead and clear this out again. There we go. Now, this might be right, this might not. But to test it, the cool thing, oops, Control Shift copy, I think you have to do. Alright. Control V. Nope. Oh well, it's short enough, we can just type it out. CYNVA. Let's do it again. There you go. So we actually encrypted our ciphertext, thus decrypting it back to plain. So whatever we put in, we could do anything. We could do hello world. Now there is one condition. Let's see. Before we get into that, so this is going to be a key error of punctuation. So let's actually do it without punctuation for now, and then I'll get into steps we can take to protect against key errors of punctuation. So let's go and clear this out. Do that. Oh, and then a space. So one quick fix we could do is a space begets a space. And that should fix it up until we try to do something with it. So, so we got a different message, but anyways, a better way. So this would be hard coding. This is that concept which isn't favorable. It's better to do things scalable to where they can grow and shrink based on different conditions. But this is hard coding, so we could do this for, and actually technically doing the dictionaries this way is hard coding, whereas what Broken said, these ways are where we can get the same things calculated. We can make the computer do the work for us rather than typing it all the way out. But again, I like seeing it kind of all out like this. So at least at first. So also we need to take off that trailing comma. So the way to get around that, well, don't do it. So don't have a space. But I mean, the good way to actually code for that, or to account for that, let's see. We got that. Control Shift C for copy. Oh no, that doesn't. Is it just Control C here? No, because Control C there. Anyways, we can type it out again. URYYBJBEYQ. So let's see if it is correct. Hello world. Now you might also notice something else. We lose our capitalization. So not only do we need to take into account punctuation, white space, we also need to take into account capitalization. If you want to create a pure like one-to-one encryption decryption ratio, so applying the same process should result in the exact same thing. So to do that, here in this loop, we're going to need to do a couple more things. So I'm going to go ahead and, we've proven that it's working with the indices, but this would be a good debugging way to check, okay, wait, what am I getting for this? I want to see what the new index is. maybe there's a bug in here if we actually did the, minus equals 25 or minus equals 27, and that would make us come up with an incorrect value. So if we tried to do this, it would be nonsensical, and actually we'd probably come up with a key error, because if we deviate too much from that, then we're going to start getting numbers that are outside of this range of 1 through 26. So, like if we're taking away too much. But anyways, so I'm going to take this one out, and then so we can kind of see what's going on here. And also, I'm going to take this one out, but I'm actually going to throw this at the very top, because this is for an ASCII thing. Let's see. To see the ASCII value of a char, use that. We don't need the double pound sign. There we go. And rather than hardcode that, oops, I'm going to say char in there. So you can take whatever char, whatever character, and put it in ORD, and then use the print function to print the ORD value of char. Okay? So we got that. Alright, so now well, first things first, let's handle the capitalization. So we're breaking this down into steps. What we're going to need is another variable. We're going to say capitalized equals false. So, ooh, there we go. Also, we didn't talk about Booleans and primitive variables. So, let's go back here real quick and throw in a Boolean. We got floats. And then put it right here. Booleans are either true or false. They are useful in keeping track of conditions. That's pretty good. And no punctuation. There we go. So, plop that down there. Oh, whoops. Oh well. Simple. Get out of here. I can't see what I'm typing. It's like if someone just put up a bunch of ads on your windshield. Hey, by the way, are you meaning this? Do you mean this? Simple bool. Because sometimes you'll see Boolean shorthand as bool. Booleans. Bools. There we go. And we have to set it to true, without quotations, because otherwise it would just be a string, and we can see that if we do, make sure it's the correct one, simple bool. Did I misspell it? Print type simple bool equals true. Alright, we're in primitive variables now, so we'll run primitive. So we got a Boolean. Okay, it went away. Whatever error I had, I fixed it somehow. So, anyways, so yes, Booleans. And then you can see the type, because we have a couple here. So, this is the third one up. So we have bool. So there's the shorthand for Boolean, and yes. So now that we have that, let's go back to functions. The reason I wanted to point out Booleans because we have capitalized equals false. So before we do anything in here, I want to do a check if char dot is upper. I want to say it's yes, is upper. So now it is helpful that it's kind of interrupting. So that is the good one. So if it is upper, so if this is true, so you're actually receiving a Boolean or a 1 for true, because you could also do like if 1. If char is upper, then capitalized equals true. Okay, and then an important thing to keep track of is you need to reset your Boolean at the end of every one. Otherwise, you're going to capitalize every single one. and then the corresponding part of that is right here. So if oops, just realized capitalized, I'm missing a D here. If capitalized, ciphertext needs to have that plus dot upper, or wait, is it two upper? I think it's two upper. And then else ciphertext plus equals, type it all out, number, dictionary, new index, oops, just that. Okay, so now without resetting capitalize, let's go ahead and see what it is, and let's go back to hello world again. Oops, and also we can't have a space yet, so hello world, clear that out. Oh, it forgot functions. Okay, so there we got that. Uh-oh, two upper. Oh, it's just upper. Okay. Alright, now as you can see, everything is capitalized. So that's a bug in the logic, and that can be fixed by changing every time, because you got to remember this is for every iteration. We want it to change after we've used it. So now we have if capitalized, now we can set capitalized back to false. Now it'll change back to false, go back through, and then we'll run this check. If the next char in plain text is capitalized, then we're going to reset that flag or that boolean, because booleans are also known as flags. I should throw that in there. We'll reset it to true, and now we're going to do that again. So let's clear all this out so we can see it clearly. There you go. So we only have the first letter capitalized, so that fixes that issue. Now the issue of spaces, punctuation, special characters, anything like that. Let's see. I'm trying to think of the best way to do it. I think we can take this out too, because this was just checking to make sure that we were getting the right indices. Is that right? Yeah, so we can get rid of that, but that's a debugging thing just to make sure that we're actually getting the values we're expecting. So if we weren't getting the correct response or the correct information out of this, then that would be one place I would check to make sure. But what we can do now is do another check. If char dot lower in alphabet dictionary, okay, and also we need to suck all of that in as well, because we want all of this to be controlled. So either the character exists in our setup or it doesn't. So that will target all white space, all special characters, which is much better than hard coding even more values and then encrypting them, unless you want them to be encrypted. So to do that, that's another place where it'd be better to do something like this, where you're just doing all of the ASCII. You would just want to include special characters, but you might have to jump around in the indexing actually if you do it this way. So if you look at an ASCII table, you know, the special characters, the capitals and the lowercase, they might not necessarily be together. Yep, exactly, Saka. That's another way to do it, and I'll throw it in there. Um, yeah, exactly. Both of you are on it. We'll throw that in there. You could do this. Let's see. So if you were to do it that way, you could do make a variable called something, and then special chars is equal to that. So then you could be checking if it's in special characters, do something. We can also check it in alphabet dictionary. Then we would do all of this. Otherwise, we need to line that up like so. Oh, wait a minute, wait a minute. Hmm. So, the way I'm doing it, we need to do new char equals something. So, sorry, I'm trying. I got too many moving parts here. Let's see. So the problem is we're adding to ciphertext the special character. So, and even if we were doing it this way, where we have like a list of them, like you guys are saying, we could do that. But then we would still need to assign new char to whatever that is. So we could do the check. If char is in special chars, then new char is set to that. Otherwise, do all this stuff. And by all this stuff, I mean finding a new index, and then... Okay, actually, never mind. We could just do this. Include all that code in here. There we go. And then we need to line it up again. And then this we need, regardless, we need to reset the capitalized flag. Otherwise, we'll still end up with, either all capitalized or no capitalized. Or no, I think it would just be all capitalized. Now, however, if otherwise ciphertext plus equals char. So if I did everything right, let's go ahead and test it with... Well, actually, first, we changed a lot, so let's go ahead and test it that it actually... Oh my gosh. Hello world. Okay. Let's make sure I didn't break anything. Okay, so it's still doing that. And now we can add spaces. First we'll test it with spaces. Okay, so it came out with a space. And now we can test it with all sorts of punctuation. Okay, and now see, the reason that, like, this is a way to do it, but I actually wouldn't recommend hard coding a set of them. You could, and that would be a good way to see, like, what you're accounting for, and especially this concept is useful in sanitizing your data inputs, which is a very, very important thing that you need to do if you're ever working with databases or anything like that. That prevents against cross-site scripting and SQL injection if you sanitize or scrub your inputs. And so that's where you would want to be doing something like this. However, here we're making it scalable by saying, if it doesn't exist, if I don't know it, if I'm not aware of it, just include it in the ciphertext. It won't be encrypted. And then we can, plop this. Oh, please work. Control C. Why don't you do Control Shift copy, Control Shift paste? See, I don't know. And then if we did it over here, well, either way for this, we could just type it in URYYB space JBEYQ. Okay, just to test again that we've got it working. There's our hello world with everything, and we can even, just to prove that this works for every character, we could plop that in there as well. Because that is a pretty concise list. I mean, kudos on that. That is nice. Let's see. Or if you want it all in the dictionary. Let's see, try except. Yeah, those are a good couple ways too. You could do a try except. Also known in Java as a try catch block, I believe. The try except is a similar thing. I don't use those a lot, but yeah, that would be like try something, and then if it isn't, the exception or the except, like do something like that. So that would take the place of this else logically. So you could do try this bit of code and then except do this, and you would still come out with a rot 13, pretty sure. So and let's see, and then string punctuation. Let's see. To test that out, let's actually do print. Let's see, string dot punctuation. Yes. Okay, let's clear this out. Let's do. Alright, yeah, and see, there's even stuff that. Well, yeah, well, there's definitely stuff we're missing because this whole thing is as big as our hello world and our included things to target. Let's see. Oh, wow. Okay, so. Sorry, I just realized what time it's getting. Gotta go eat some dinner soon, but oh no, what did I do? Sorry, I clicked the wrong thing. Let's clear this out. Alright. Okay, but that's a rot 13, a fully functional rot 13 that takes into account white space, special characters, as well as a handy way to print out every single special character, or all the special characters included in the punctuation, um, I guess, list, set, or group, string. In fact, I wonder, does it call this a string? Let's see. Yeah, okay. So that's a string of punctuation in the string library. And remember, we had to do import string to be able to use stuff from the string library. So, like, this is from the string library, string.ascii lowercase. I imagine there's an uppercase version as well. And then string.punctuation also comes from that string library. So, important to note. Let's see. I'm trying to remember what other concept I was wanting to get into after encryption, because encryption is just a really good example of. Oh wait, what's going on here? Oh, nice. Okay, sorry. Someone else I follow is doing some Minecraft things, so that might be who we raid here in a little bit. It'll be kind of funny because they usually have a ton of people watching, but let's see. Any requests for what we should talk about for the last 20 minutes? Because if not, I'm thinking. Oh, well, looking back at the Java page, I'm trying to think of things that we didn't. Well, and here we're using switch cases, so if you want to see how ugly it can get in Java to do the same algorithm that we just did, let's go ahead and widen that. Come on. Oh, can I not? Oh well, anyways. So you can see here's the rot 13, and since we're doing Java, we have to do our class declaration line. That's our comments in there. But anyways, our dictionaries are replaced with this. Hey, what's up, Chanturius? Welcome, welcome. So, but yeah, this is replaced by a dictionary. So we've got all of these different things. Yeah, all compacted into this, which is still very lengthy, very verbose. Hey, what's up, Zaf? Welcome. Thanks for the congrats. Yeah, made it like Tuesday. And actually, I was just talking about rating the guy that made it possible. So we might do that at the end of this stream if because he's streaming some Minecraft right now. But I might do like a mini raid. But anyways, let's see. You can do switch case in Python? That's interesting. Let's see. Cause yeah, I mean, I'm trying to think of the benefits, well, yeah, it would be nice to be able to do switch strings because I'm trying to think of a good example. I don't know if I have. If I were to show the example I have from Code Wars, we'd have to go scroll through all of the challenges I've done, which is up around 360 now. But there is a way. Basically, the only thing that you're missing out on with using a dictionary is you would need to. You can't execute code. You just get a value back. Whereas with a switch statement, I think you can assign variables based on the case. So if we look back at, oh no, that's the Python, apologies. If we go back and look at this, each one of these cases, you can actually do some code execution in that case. So like right here, I'm just reassigning return int to the new value, and then, you know, doing the break, so you break out of it, and then the default. Whereas I'm thinking of this one particular example, let's see, in 3.10, nice. Yeah, I really need to update my Python. I think the one that I use on my VMs offline is like Python 2.2. So, but I mean anything that I have touching the internet I try to have updated, but I'll have to check that out. That's interesting. Cuz that created a whole like thing. It's just cuz I think I tried to do a switch statement on one of the Code Wars challenges. And then in fact we could even pull that up real quick. We might as well. Let's see. Code Wars. Oops. And then, sorry if this makes the chat lag. Let's do my Code Wars. Oh, jeez. We gotta throw it in there. Alright. So, here's my Code Wars. And if we look at the solutions, and then we go all the way down. Yeah, and then you'll notice most of them are white labeled, which are the easy. I was trying to do all the low-hanging fruit I could just to get to a level 4 Caillou, or get down to. I guess it's kind of backwards in Code Wars. So if you're not familiar with Code Wars, you start at a level 8 Caillou, like this, the easiest, and then you move down to the bluest of blues. So there's actually like a purple for level 2 and level 1, I believe. Now I'm about halfway to level 3. Don't worry, we're almost there. We're getting down there to the nitty gritty. Let's see. Almost. Sorry. I mean, it's just... It was the very second challenge I did. You have to do a very easy challenge just to get into Code Wars. Let's see. And all of the harder challenges are on my GitHub. So if you are curious about any of these, like the oranges that we've seen peppered in through here, like this one. Once you get 6 and 5, you get to that yellow orange. And then once you hit 4 and 3, you get the blue. There we go. There's one. So that is a massive if-else statement for alphabetic position. So all of this code, let's see, sorry, let me pull the back up. Yeah, gross. This is very gross. So, this actually, if we go back to what we were doing in the Replit, that's it. This single line, you know, you're enumerating you're creating a dictionary on the outermost part of this line, and then you're enumerating, so you're giving numerical values to all of the values that are returned from this command, string.ascii lowercase, and then you're starting at position 1. So yes, this line, line 21, is the equivalent of all that, literally, to 26. So, and also you'll notice in here I'm hard coding spaces in there too. So this was before I realized there were helpful functions like join, where you could actually take a list or an array of values and then join them on spaces. And then you would also get away from slicing to the last indice like I did here, because this is hard coding targeting that last space that is inevitably added. In fact, I think the whole point of this challenge, which is interesting that it's a 6, because this was a pretty easy one. Granted, maybe that's why, because people would do something like this and struggle through it. So, I don't know. But yeah, by doing this, you're chopping off the last space, and then all this does is this. Oh, I could have actually been casting this as well. Well, either way, it's very bad. So it's funny. That's the only one that it shows me. But anyways, Code Wars is fun. If you ever want to do challenges, like they have some really cool ones on here. And I was gonna start doing oh, interesting. I was starting to do this on stream because I wanted to. Oh, followage? Oh, I haven't actually activated any link bang things yet, but that is coming up soon. I will be doing that soon. I'm also working on new emotes. It's kind of getting dark in here, but actually, let me turn the light on real quick. Bada bing. I'm working on new emotes. I'm going to do the red octopus. So that's my rubber duck in my programming environment. So let's see. It's probably a 6 in other languages. Let's see. Yeah, and the switch statements, there are ways around it. Like we saw in Replit, you know, you've got a couple of other tricks that you can use. You can hard code the dictionary, write it out like that, or you can use, you know, these your little one-line zingers like that. And if you're doing clashes, you're gonna want this way. So, oh no, I'm actually making the emotes. So I used to be really into art, and actually my profile picture is one of my old graffiti tags. Actually, let's go ahead and, yeah, see, that's actually something I came up with a long time ago. I've just been drawing it for a long, long time. So, in fact, and then my background as well, you can see that's actually the Sharpie that I did to just draw on it. So, I mean, if it ain't broke, don't fix it, right? So, if I ever get famous, yeah, I'll probably pay someone to do some graphic design. But until then, I mean, I'm just gonna draw my own, or take a picture of the Rocktopus. I might figure out a way to do that, because I don't know. I mean, as it is, my profile picture is just something I just whipped up. So, um, yeah. I'm trying to think. Yeah, we're still pretty early on the 2 hours. What else do I go about Java? Let's see. Oh, that's this is all still the encryption algorithm. That's so these switch statements are just about as ugly as well. So they're lengthy. They're, yeah. And then that's the, oh, I have it broken up into whole different. Oh wait, no, this is the actual encryption method. Hold on. So we have a lot of the same concepts. We have a Boolean, we have chars. Notice in Java you have to actually declare. So that's kind of nice about Python. You don't have to worry about that stuff. Yeah, that's a lot of, yeah. What I was more interested in is, let's go back to a concept that we could talk about in Python without getting too, let's see. Yeah, definitely. Let me know what you want. I'll try to draw it up. I mean, I'm not a pro, but I'm not a pro coder either, and I'm having, you know, a lot of fun teaching coding, so. But yeah, I did some I did some graphic design back in the day during my degree too, because I did some web development and then I had to do some logo creation. So I actually made a few logos. One I used when I did a coding competition at CSU with some friends, and it was the Windward Code Competition, which is awesome, an artificial intelligence type thing, and yeah, Java Advanced. There we go. And I did a logo there, and I used GIMP. I mean, if you use Linux, you can use GIMP as a free image manipulation software, and you can save it in all the different file formats. It's not as good as Adobe Photoshop. It's not as user friendly, but it's free. So, I mean, there's that. Um, yeah, and we talked. I'm not quite to data structures. We could start talking about it. I'm not sure about doing inheritance and file input output without doing some prep, because file input output with Python, it's more like C++. You got to do like a file handle. I don't actually have it for Java. That's one of the things I'm lacking. I have other objects and it starts right after that, so that's what I need to finish up. But we did hit recursion today. I don't know, actually, I'm thinking, let's do a couple clashes. Let's see some of this in action. Coding in action. There we go. Let's go close out Code Wars. Feel free to follow me on there. I'm not super active on it now. I got to that rank and then I was pretty happy. So now my whole focus is this coding clash, which I'm at 1097. So, alright. Let's throw that in there for anyone who wants to join. And yeah, we'll do a couple clashes, hit that, at least that 2 hour mark, and then, yeah, that might go for another walk. And I actually have a thing going on here in a couple hours, another phone call. And then, oh, Carpin's on. Actually invite everyone. Well, I think Mawa's like me. I often leave this thing on. So, yeah. Okay. I also need to add music. That's the next thing. So I need to. Alright, so fastest mode. You work in NASA and must check if the rocket will reach Mars. Problem, you must create a program to calculate if the rocket will reach Mars. Criterion of a failing rocket. If the velocity multiplied by the time is less than distance to Mars. If fuel multiplied by fuel consumption is less than distance. Oh, okay. So, we're going to have a couple of different conditions. So right away I can tell I'm going to need, if something, I'll do if 42 equals 43 for now, just as a placeholder. We're going to do that, print. Ugh, that looks ugly to me. Normally you want to use double quotes. I mean, you can do it in Python. You can get away with using single quotes, but it just looks weird. So, and then okay, elif 42 equals 44, print. Let's see, we did not enough time, now we need not enough fuel. Okay, there. Oh no. End. There we go. Not enough fuel, else, welcome to Mars. And actually, I didn't see, that should be the only conditions that will cause a failure. So you're either failing because you don't have enough time, either failing because you're not enough fuel, or welcome to Mars. Also, this is a little off. Okay. So we have distance, time, velocity, fuel, fuel consumption. So let's look at an example of what we're working with. So we got distance, time, velocity, fuel, fuel consumption. Let's see. So if we were to change that, okay. So the first condition, if time times velocity is less than distance, don't know if that's going to be right away. And also, you usually want to, enclose these in parentheses. So if that's less than distance, not enough time. Otherwise, if, let's see, fuel consumption times time is greater than, wait a minute. Fuel consumption times time is greater than fuel. So if it's equal, in theory, the rocket should still make it, just barely. Okay, let's try that and see how far off we are. Alright, got a couple. Alright, failure, not enough fuel. So what I'm going to do is throw that equals in, and let's see if that was the corner case I was thinking of. No? Let's see, what are the tests? Wait a minute. Both. Welcome to Mars. And we're getting not enough fuel? Let's see if that's a corner case that was explained in then. Huh. I mean, we're very close. Like 80 to 90%. Or no, I guess what is this? 3 out of 4? 75%? Alright. But still. So we're getting a false positive trigger causing it to hit this one. So fuel consumption times time. I mean, I doubt this is what it is, but like I was just talking about on that first part. Yeah, that didn't change anything. So this is more just to make me feel better that it's actually functioning as expected. So taking like the whole distance in the parentheses and comparing that to the thing. So it works for every other situation. Let's look at the tests. Well, let's see what's going on with the failing test. So it's going... let's see, can I put all that on the same? Alright. So wanted to pay attention. So we have time, fuel consumption. So fuel is that. Or no, distance is the very first one, right? No, distance is the last one. So... yeah, money gas. That's a thought, and that would actually be what I'd think. But we had that initially. Um, yeah, that's why I'm so confused. But good thinking. That's what I would look for. Because we're comparing it to fuel. Like if we don't, that's why I was kind of like going back up here. Oftentimes I go too fast without reading this. So let's see. Okay, and we do take care of this condition by the ordering with which we check the two conditions of failure. Let's see. If rocket is successful, print welcome to Mars. Fuel will be in liters. Fuel consumption will be distance per 1 liter of fuel. Distance will be in kilometers. Now that, I could see this being an issue, kilometers. Let's see, is everything else in kilometers? Which makes me think that it's not that because we passed the other ones. And so if it worked for 3 test cases, then conversion of units shouldn't be an issue. Unfortunately, their test cases are so, like, that's kind of too hard. I mean, this is hard to do in my head, and it's only working with tens. Like, it's not enough time because, and again, we got to go back down to... So right away, I call shenanigans because we've got 5 inputs. So then you almost have to look here. We've got distance, time, velocity, fuel consumption. We're missing velocity here. So that might be a criticism that we should say on the feedback. And then all of those will be between that. So that's not super helpful. So anyways, we're missing velocity. So if we were checking and velocity's right in the middle. So if we look at that test case again, we've got time. So we have 1,000 seconds. We go 10 meters per second. Or no, we have 10 fuel. And then we've got 10 velocity. So we move 10 meters per second. Or 10 kilometers per second. Because again, uh-oh, what's going on? 1 second. Okay, cool. So, I don't know. Then we have fuel consumption and distance. So we're trying to go 100 something, 100 kilometers. Distance will be in kilometers. But then I think it's something multiply by 1,000 or divide by 1,000. Just the conversion between kilometers and a meter. So that's the only movable part that I can think of that would be affecting this. And then in order to do that, we divide by 1,000 here. But then our time is mass of 1. And that might break everything else. Let's try it. Double divide by 1,000. We're going to essentially do a unit conversion, which really bugs me whenever you have to do that in a challenge, but I guess it is still part of it. Alright, so it broke it. So not enough fuel. The time divided by 1,000. So no, that was... Oh well. Either way, we're going to be second place. I mean, because we got it second. So I'm going to go ahead and submit. I don't know if you get lower points for, Wait, what? Okay, never mind. We weren't passing a test. We still got 100%. Alright. So yeah, I think you were right, Money Gas. It needs to be greater than, and that's what we had in the beginning. But then, Okay, let's do another, and then... Actually, yeah, we'll do one more, and then we'll see if any of these gents are on. Apologies if you're not. Sorry. So, yeah, alright, there's Mawa and Carpin. Nice, welcome. To the clashes. Alright. And a robot. Bitwolf. So, and I don't know, Zeph, are you still in here? Because if I can't find... Or, well, I guess we were gonna... I like to keep it similar to, like, coding things. But don't get me wrong, I still randomly. And I might do some game raids, too. Or game streams soon. But, I think we might actually be rating Anthony Wright's code. Because that's actually... He's one of the ones... I think he's doing some Minecraft. But it would also be good to... He does a lot of really cool code stuff, so... But I was gonna say, Zaf, if you're streaming, we might raid you, but... I might keep you in the options. Just have a bunch of computer nerds raid your channel. Zaf is pretty cool too. He does a bunch of variety game streams. I don't know what you'd classify that as. A lot of games. Can we launch it? Oh, there we go. Here we go. Alright, so another facets. Given an ordered sequence of English months, first letter output the next one. Okay, so there is always one and only one solution. Ooh, wait, what? This is really confusing at first. Let's look at a few tests. March, April, May. Okay. So my initial thought is to make a string with all the months. January, February, March, April, May, June, July, August, September, October, November. There we go. That's most of them. So month string equals that. So there's all the months. So now we would do substring. Let's see. Oops. So how would we do that? So O and dang, someone's already got it. All right. Oh, nice, and Carpin's got it. Not surprising. Ooh. Okay, so right there, hard coding might actually be the way to go, because whatever the last one. Yeah, a cleaner way to do it would to take whatever it is, you could modulo it, or you could slice it to be the same size as your string, only with the substring at the end. So to enforce it, it's only 12 long. You could make months into that. Let's see. Look and see if, because I'm thinking I could do some hard coding. Yeah, there's only going to be 12. Let's see its fastest. Let's see. If once -1 equals elif equals January, February, March, April, May. Oh, A appears twice. Yeah. It can be. It can be hard. It can be easier. You're right. All coding is hard. I mean, it takes practice, years studying. I don't know. Or just a lot of coding game clashes, which I'm actually struggling pretty well with this, because already I'm seeing, if I was going through and looking through all the ones where there's only one condition, so like the F would only yield an M. However, an M will give you an A, an M will give you a J, and then an A will give you an M, A will give you an S. Well, S is a unique condition. It'll always be, for September, we're always going to print October, and then, oops. Oh well, it's ugly, whatever. elif months at -1 equals equal to O print N. Okay, so we've got those conditions, and if D elif month to -1 is equal to a D, then we got January. Okay, I think those are all the conditions that we know for sure there can be one and only one. Need to spell it correctly. Okay. Alright, so no matter what, if we get that as an input, an F, an S, an O, or a D, then we already know the answer. Now, if it's another condition, elif months at the end, so again, this will take care of that issue of having a really massive one. And so, yeah, we got 9 minutes. We should be okay. So, if it equals a J, let's address that first. So now, if months -2 is something. So now, let's see, what are the conditions of a J? So it's either, if it's a D, then we'll get an F. So, yes, exactly. We're going to look at the one even further back to tell what we should print. So now that's going to be an F. Now, there's another condition if it's a J, so that's for January, and then June, we would do this same exact thing. So I'm just going to copy this. And yeah, this is going to be like almost a 12 there. Otherwise, if it's a J and then this is an M, then we get a J. And then another one, if it's a J, then we get A. And then I think that's it. It's for the J's. Now we got to do A. Okay. There's only 2 of these. So we're looking at A. If it's an A and the last one is an M, we get M. Oh. No, that is right. If we have M, we get M. And then we can do it again. For the other A, that means if we get a J, we get an S. So A, J. So wait till you see Carpins. It's going to be just like a couple of lines, and it's going to be ridiculous. So A, the last 2 is J, then we get an S. What am I forgetting? Do we do M's? M's. Okay. Oops. And we can use that same structure. So if it's an M, and then we either have an F gets an A, so we'll do that. Okay. And then we'll do the very last one. If it's an M and it is a, we get a J. So M, A, J. Let's see. What's the question again? Oh, it's printing the next month. So what we're trying to do is based on an input, else print fail. It should never hit the else. It should, if we did this right. Oh, wait. Expected J. Yeah, I know. It's not the cleanest. It's not the, but, I mean, what's going on? Okay, so what are we failing? Summer's coming. Let's see. Posture check. Let's sit up straight. Alright. So we got, so if it's an M, and then if the last one's an A, we get a J. So if it's an M, oh, that's, no, we should get that here. But we get nothing. So if it's an M and an F, MF, I mean, is that logic just broken? Yeah. M, A, and J. Let's see. M, A, and J. It's all lined up the same, so it'd be breaking elsewhere. Let's see what the other one is. Let's see if we can fix that one. D. So if it's an N, okay. That was the one. Or no, did we not have a condition in there? Oh, it doesn't look like we have one in there. So to fix that, we go back to here before we start getting all complex with double conditionals. Elif months at -1 is an N. Yeah, you'll notice it's ugly because I've also been using single quotes and double quotes. Print D. Alright, so now we should pass that one. Okay. So now we're just messing up with the ends. So we got 3.5 minutes. And we can't test all of them because we failed on the first test. So everything else still works. I think we're at the 80%. We're the last one clashing. Let's see if we can just find it just real quick. If not, yeah. Let's do... What are the other conditions? So we're not getting out of range. We have an M that we're checking to see if... So this should trigger it. And this should trigger it. So if it's M, and then the one 2 back is A, out of curiosity, print here, question mark? No, it didn't even get to there, so I got it. And there we go. -2 equals F. There we go. Alright, we're kind of muddled through that. So, let's actually do one more. I don't really want to end on that note. That was kind of bad. Oh, and I still got 80%. What is that? I think because there was that same issue with the other double letters. Oh well. Can't win them all. Let's do another. And then I'll go grab some dinner. Let's see. And I think we shall raid Anthony, who's not coding right now, but he's doing some Minecraft. And that's another thing I like to stream a lot of, so. Let's see. Karpin and Mawa. They might be in other clashes too. I kind of took a while with that. Ugh. Nice. Oh shoot! I didn't look at the other solutions. I was just gonna say, Karpins are always usually very short, succinct, and especially even more so because he uses Ruby a lot, or they use Ruby a lot. Let's see, where's everybody at? Texas, Australia, a robot. You know, Karpin's from Germany. Got France. We got the U.S. We do have the chat there too. Oh. Okay, so shortest mode. I'm going to do terrible with this. Check for balance, brackets, parentheses, and expression. Okay, cool. So... Okay. Stuff equals line dot split. Valid equals true. In stuff, if item is equal to whatever that is, because it really doesn't matter. You can make a bracket out of anything. There. Count plus equals 1. Elif item equals brackets with the underscore on the other side, right? Oh no. It's backwards. Okay. Again, doesn't matter. It's inconsequential as long as you are working with the correct thing. So, got that. Into account. C equals 0. C. C minus equals 1. If C less than 0, v equals false. If c is equal to 0 and v print balanced. Is that what we're printing? Balanced, not balanced. Don't forget the D. Else. See, and I got a little more time because everybody's shortening up their code. Not a whole lot though. Balance. This Carpen's still really quick. There we go. Invalid syntax. Okay. Oh no, the robot did it quick. What? Okay, so there's certain conditions that I'm giving false positives for. And I think it might be because of this part. Checking to see if C ever dips below 0, that means that they're not balanced because you have an opening bracket. No, you have a closing bracket before you have a corresponding opening bracket. So without this little bit of code, you know, you could check to see that there's an equal number of normal forward brackets and backwards brackets. Let's actually see what these tests are that we're failing. Not balanced. Okay, and we're calling it balanced? Oh, right. So, so if this never gets entered, how do we fix that? I know how to do it length here. I'm just trying to keep in mind we got to make this short, because that is shortest mode. So already we can take some of this out. I know how to do it. I mean, well, we could worry about size after we do that. So if actually I equals 0, and I not equal to 0, there, we can now keep track if, you know, if we actually went into this loop. Meaning, if it was big enough, if it actually had an opening and a closing bracket. There we go. No, still, what's number 3? So we have an opening, and then we have a closing. Okay. Wait a minute. So we have an opening, we have another opening, and then we have a closing. So our count should have incremented by 1, incremented by 2, and decremented by 1, equaling 1. So if we print out, let's actually see what C becomes for this situation. So 0. Let's see how it changes in the loop. It doesn't change. Oh. Okay. Dot lower. That's all we gotta do. There's a capital B. Alright, let's take back the... Well, let's see if that actually does it. There we go. Okay. Alright, now the very last... No? 7, 8, 9, and 10. Jeez. guess I should have read the directions. Sorry, let's see. A word beginning with an underscore is an open bracket. Okay, so that's why, because we were targeting. All right. Um. Okay, so for item in stuff. Are you in this one, Money Guess? So, the open and closing brackets, and actually I have a nifty replit that shows the actual permutation of all of the different combinations and permutations of brackets you can have. In fact, I'll try to look at that after this. But, so here, let's see, brackets, I'm not worried about length just yet. So we're going to make brackets an empty list. If item at position 0 is equal to an underscore, then it's a bracket. So brackets dot append item. Now I'm also thinking, so that's how we get all the brackets. This is just an initial check of all the brackets, because I'm guessing we're going to need to keep track of types of brackets. Like if you look at here, this bracket, this is a bracket, this is a bracket. So then it should have a corresponding backwards, 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 you see. So this is still considered, which is weird. Never mind. Let me read the directions again. Yeah, so here they have two different types. And so how we do that is we can do start, end, and then -1. So could do if it was only custom. So yeah, basically I'm failing these things because I'm hard coding brackets. So then we would have to do for item in brackets for every type of bracket. We need to keep track of the count. So let's actually try that since we're getting nigh on. We got a little under 5 minutes. So for thing in brackets. Okay, so, and then we're going to do that we're going to loop through that. We're going to loop through stuff and check to see equals thing. Otherwise, if it equals thing but backwards. Okay. No. Did we break everything else? We might have broken everything. Nope. What's number 3? So we have an open and a close. Oh, right. So we need to reset C equals 0. No. If C is equal to 0, V equals false. Or no, not equal to. There we go. Because, oh man. I might have buggered this one up. We got like 3 minutes. Okay, so 0 is supposed to be in perfect balance. If there's as many left side as there are right side, it should still equal 0. Because we're changing C every time. We're increasing it every time we see it forward, and then we're decreasing it every time we see it backwards. And so, and if at any given time that C dips below 0, then it's not valid because, oh, actually wait. That might be why. Never mind. This is only used... I mean, this might have broken another one where we're giving a false positive. So it can dip below 0 as long as it comes back up, unless it starts off that way. So if you look at what I mean by that, so that one's okay, that's a balanced one. Here we've got 2 left side, 1 right side, and 1 right side, so that's balanced. But if you had it, that's unbalanced. Okay, so then we have a left, then a right, so that's okay, and then another right, so that's not balanced. You just couldn't have a right before you have its corresponding left. You have all except for 7 and 9. Which one are you, Broken? Are you... Oh, either way. So the only reason I would have this condition in here, I mean, I'm going to put it back in because now that I've done it for multiple brackets, I've introduced a problem of having to reset variables, which, you know, I'm trying to fix with this. Yeah, you've got everyone except for 90%. Oh, are you BJQ or BQJ? I mean, nice. 90's good. I'm getting nowhere near 90. Let's see. In fact, I think I even broke. Yeah, now it's all just broken. In 32 seconds. Let's go ahead and do... Yeah, whatever. I'm not going to stress and try to get it the last 20 seconds. Oh, we got 60%. Let's see what you did. Okay. Oh, I see. I think the one that you might have been messing is that one I was talking about. If it starts with a right side bracket, then it makes it invalid. So if at any given time you dip below that 0, because you should always have, the count should always increase every time you get a left side, and then decrease accordingly the same amount with the right sides as they show up. But if you have a left side show up before a right side, you're going to go below that 0 because it'll subtract 1. And so that's how you can tell. And I think that's all you're missing, because that would make sense, because it looks like you're just keeping track of... I mean, I might be wrong, but I think that's why, because... I mean, it's definitely a lot smarter than all that nonsense I was trying to do with lists. You're keeping track of just the underscores and the spaces. But if an underscore... So if this were to happen before a B, if you got a B before an A, then it's invalid because you're trying to close a bracket set that you don't have opened. So, let's see. Yeah, Ruby, 138 characters. Boom. And then there's so much going on here, I have no idea. Position. That is just so complicated. Let's see what Mawa did. Yep, so very similar. Yeah, and that one confused me too, because that looked like it was legitimate. Because you've got Clash one way, and then you've got Clash the other. I mean, can we see... I don't think we can open up the test cases post-Clash. But yeah. Yeah, that one confused me too. They were out of order? Okay. So, that makes sense. If there was... Yeah, then you just have a right before a left. So, but otherwise, nicely done. Like that's a lot smoother of an algorithm, just counting those. And same, of course, with Carpin and Ma was. All you guys, yeah. So you're doing that. Hmm. Interesting. Huh. Well, we got another Python. Yeah, looking at the counts of those. So I wasted a lot of time trying to worry about just brackets, hard coding that. So, all right, cool. Well, that was a lot of fun. I went a little bit over the 2 hours that I was planning on, but let's see. See, Anthony is still on. I didn't understand this challenge actually. Okay, well, actually, real quick, let's talk about it. So, this challenge, if you have actually, let's look at this because where did I put that? It's in the I want to say test 3 replit. By the way, anybody can go and check out my replits and see all of these things, but I want to say it was in test replit 3. I know a couple are empty, but I actually have. No, this is some hash stuff. No, let me find. Is it the first one? Let's see, sorry. Yeah, sorry, that is something I'm looking into fixing. Here it is. So if we run this, never mind all of this stuff, but yeah, I need to cut down that delay. I think it might also be part of my internet too. It's not the best. But if I start, I might invest in better internet soon. I think there's a deal actually going on. But here's basically highlighting the concept of valid brackets. So this is every permutation of valid brackets of a given size. So I think don't worry about that. That's a Code Wars thing. Sum of cubes, that's a different thing. Here we go. This section of code, print parentheses. I'll actually throw that into. Can I put all that in chat? Reached character limit. Let's see how much. Oh no, it won't let me. Ew, that looks ugly too. Let's see. Oh wait, how did you find that? Is this the clash we just did? It's going. Okay, cool. Yeah. Did you just write down the name like when we were doing the clash and then look it up that way? I mean, this would be easier to explain. Oh, real quick, let me finish talking about this. So, if you went through and checked each one of these would all have valid parentheses or valid brackets. This is just, I think it's just cool because you could do. Oh, whoops. Well, not that anyone used the. It's on my Replit if you want to copy the code. It's in test REPL, but basically that's how you get every different combination of brackets. And then here, what the challenge was doing is, let's see if it has the a condition or a phrase is considered balanced if you have the same number of left brackets as the right brackets. Yeah, yeah, that'll happen. So, and the trick with this one is they actually made brackets be multiple things. Okay, yeah, here's all the test cases. So here we have a balanced one because here's an opening bracket. Anything that started with an underscore was an opening, and then everything that ended with an underscore is a closing bracket. And so that introduces a couple of corner cases where, so this is balanced because even though it's a different word, it's still an underscore beginning. It's a word that starts with an underscore and then a word that ends with an underscore, and those words are the same. Oh yeah, they have to be flipped. That's the other condition. So, whatever this opening bracket is, its reverse is its corresponding closing bracket. So, and actually, if we get down to the tests, let's see, what was like the last test? Or wait, you said you got test 7? See, so no hard coding here, and then you get the reverse here. Whoops. So you get the reverse for that here, and then hard coding if that is H hard coding. Yeah, that looks right. And then no. No hard coding here. No hard coding here. Yeah, so this would be a set, and then the outer set would be the hard coding, and then the no. And then, let's see, another good one to look at would be clash of code. Here we go. So you have code, so this is a set, but then you have the of. Ooh, a validator 7. Oh, oh. Yeah, yeah, this is a similar situation. So here we've got an opening, closing, and then a closing. Ooh, that's tricky. I'm not even sure how you would code against that because so you have an opening. Oh, okay. So what you would do? Wait, no. I don't know what that would be, but I mean to put it'd be the same as if like. Well, actually, that's kind of confusing to look at. Oh, that's interesting. That's a cool case. Well, I've definitely gone much past the 2 hours I was shooting for this. I'll be uploading this to the YouTubes here shortly, but I need to go get some dinner and stuff. Thanks for stopping by, everybody. It was fun. And yeah, I'll, wait, hold on a second. I'll go ahead and throw you on a follow. There we go. So, because generally I invite people if I'm clashing. So, I mean, usually I'll try to stream, but I'll also be clashing without stream sometimes too. So I see my little logo pop up. But for now, let's go ahead and pass this off. Let's do. Yeah, because that's. Well, even with a stack structure, because you've got two parenthesis sets that are contradicting or they're like intertwined in a way that makes it fail. I guess is kind of like the best way I can describe that. So, I mean, because you can't have. Yeah, it has to be some kind of stack structure. So every time you can increment it or you can pop it. I mean, that is one way. Oh, well, I'm sorry, Malwa. Were you saying something? Here, let's see. Yeah, yeah. It was pretty intense. But yeah, thanks. You too. I'm gonna rate us, Anthony. Feel free to stick around. This guy does a bunch of really complex coding stuff. He's doing Minecraft stuff right now, but code. We'll pay back the raid. All right, with the few of us that are here. So, all right. Everybody's ready to raid. Okay, and here we go. Thanks, everybody. See you guys later. All right. Everybody's ready to raid. Okay, and here we go. Thanks everybody. See you guys later. Alright. Who's ready to raid? Okay, and here we go. Thanks everybody. See you guys later.